Assalamu alaikum. I am Dr. Abrar and I am going to explain the properties of ionic compounds and how the properties of the ionic compounds are linked with ionic bonding. So let's start. So ionic compounds, as I also mentioned in my previous lecture about the ionic bonding, so ionic compounds are formed between metals and non-metals due to transfer of electrons. So where metals lose electrons, remember that metals or the metallic atoms, they lose electron because they have one electron in their outermost shell or two electrons or maximum three electrons in their outermost shell or valence shell. So therefore the metals lose electron, and by losing electron they form positive ions. How they form positive ions? Because once the electrons are lost, so the protons are increased, because originally every atom has equal number of protons and electrons. So once the electrons are gone away, like one electron or two electrons or three electrons, they are lost. So as a result, the metals, they form positive ions like +1 charge or +2 charge or +3 charge, right? So, and on the other hand, the non-metals, the non-metallic atoms, they gain electron. Why they gain electron? Because the non-metals, they will be having either 7 electron in their outermost shell, so they need 1 electron to complete the shell. Or if they have 6 electron in the outermost shell, for example in case of oxygen, so they will need 2 electrons to complete the shell. So in this way the non-metals will gain the electron, and when the non-metals will gain the electron, so they will form negative ions. Why they will form negative ions? Because of the reason that they will get 1 or 2 or 3 additional electrons, because of the fact that they will get 1 or 2 or 3 additional negatively charged particles, electrons. That's why they will form negative ions. And remember that negative ions are called anions, and on the other hand positive ions are called cations. So we will summarize that the metals will form positive ions, cations, and non-metals will form negative ions, anions, in ionic bonding. So, and when there are positive and negative ions, and when there are positive and negative charges in the ionic bond, so therefore strong electrostatic forces of attraction are established between positive and negative ions. This is short form of positive and negative. So there will be strong electrostatic force of attraction. This is the characteristic feature of ionic compounds. What is that feature? Strong electrostatic forces of attraction between oppositely charged ions. Let's take the example of an ionic compound, that is sodium chloride. The formula of sodium chloride is NaCl, where Na is sodium, its proton number is 11, and if its proton number is 11, it has electronic configuration of 2, 8 and 1, where 2 electrons are there in the first shell, 8 electron in the second shell, and 1 electron in the last shell, in the outermost shell. This is the electronic configuration of sodium. Now come to chlorine. The proton number of chlorine is 17. So obviously it is having 17 protons and 17 electrons. And how these electrons are arranged, that is its electronic configuration. In the first shell 2, in second shell 8, and in the third shell 7 electrons. Now chlorine is having 7 electrons and it needs just 1 more electron to complete the shell, where sodium is having 1 electron in the valence shell. Now it loses the electron, and when it loses the electron, so when it loses the electron, for instance sodium will lose the electron and chlorine will gain the electron. So when sodium will lose the electron and will give this electron to chlorine. So instead of 7, now we will write that chlorine will be having 8 electrons. Now it will turn into chloride ion, -1 charge, and sodium, after losing electron, will be having +1. Why it will be having +1? Because it lost electron, and because of the losing electron, now proton got in excess. So that's how sodium turned into sodium ion and chlorine turned into chloride ion. Now it will be called chloride ion, not chlorine. Chlorine is the atom, chloride ion is the ion, right? So as I wrote sodium with red and chlorine with blue. So this red one, this is representing sodium, and the blue circle is representing chlorine. So this is the ionic lattice of sodium chloride. So if this is sodium, which is having +1 charge, because it is the cation, it lost the electron, and after losing the electron, now it got +1 charge. On the other hand, this is the chloride ion. It gained 1 electron, so it has the -1 charge. So on this corner it is sodium ion, on the other corner it is chloride ion, -1. And if this is negative ion, this is sodium ion, positive ion. This is positive ion, this is negative ion, chloride ion. This is sodium ion, this is chloride ion. Alternatively, in the ionic lattice, the positive ions and negative ions are arranged alternatively in the ionic lattice, right? So and these lines are representing the electrostatic forces of attraction. So there are so many electrostatic forces of attraction between the positive and negative ions. Electrostatic forces of attraction, electrostatic forces. So here electrostatic force of attraction is acting. Here the electrostatic force of attraction is showing its effect. Here between the positive and negative ion, the electrostatic force of attraction is acting. So there are so many strong electrostatic forces of attraction between the oppositely charged ions, and this is the characteristic feature of ionic compounds. And because of this strong electrostatic forces of attraction, now let's see that what will be the effect of this ionic bonding, and what will be the effect of these strong electrostatic forces of attraction on the properties of the ionic compounds. Because of this strong electrostatic forces of attraction between the positive and negative ions, ionic compounds show higher melting and boiling points. They have very high melting and boiling point. For example, in case of sodium chloride, the melting point of sodium chloride is 801 degrees Celsius, and the boiling point is above 1400 degrees centigrade. Why they have so much higher melting and boiling point? If someone asks you why ionic compounds have very high melting and boiling point, so you will give the reason. Your answer will be that as ionic compounds have positive and negative ions, and there are strong electrostatic forces of attraction between the oppositely charged ions. Because of these strong electrostatic forces of attraction, it is not easy to overcome these forces of attraction. A very high amount of energy is required to overcome these. A very high amount of heat energy is required to overcome these forces of attraction. Therefore, ionic compounds have very high melting and boiling point. Another property of ionic compound is that they are non-conductor of electricity in solid state. So why ionic compounds have they are non-conductor of electricity in solid state? This is because that in solid state the ions are held at their fixed position in ionic lattice. In ionic lattice, I am writing the spelling of ionic lattice. In ionic lattice. So in the ionic lattice of ionic compounds, the ions are held at their fixed position. They cannot move and they cannot carry the charges. And as they cannot carry the charges in solid state, because they are held at their fixed position, so they cannot conduct electricity. They cannot carry the charge. But when they are melted, when they are in molten form, so now you know that in molten form they are turned into liquid. Now in liquid state the ions can move freely. Or the other possibility is that dissolve these ionic compounds in water. This will be called aqueous state. So in aqueous state the ions are able to move freely. And once the ions are able to move freely either in aqueous state or in molten state, now they can carry the charge. And now they are able to conduct the electricity. So this is the reason that ionic compounds can conduct electricity only in molten state or in aqueous state, because in aqueous state water dissolve and break down their ionic lattice, or once they are melted, so in molten state the ionic compounds, their crystal lattice is broken down and now the ions are able to move freely and they can carry the charges. So that's how we can link the properties of the ionic compound with their bonding, and that's how we can link the ionic bonding with the properties of the ionic compounds. So in the exams the students will be asked to link the two things, that the ionic bonding you are able to link it with the properties of the ionic compounds, and you should be able to link the properties of the ionic compound with the ionic bonding. So now let's come to the questions. So now I picked some of the questions from the past paper, some MCQs. So let's see and solve these questions one by one. Question number 1. How does a magnesium atom form a bond with an oxygen atom? So now here magnesium is a metal and oxygen is a non-metal. So it means that they are talking about ionic bond. And in ionic bond, the transfer of electron takes place where a metal will lose electron and the non-metal will gain electron. So it will be A, because by giving one pair of electron to the oxygen. Why one pair of electron? Because magnesium will lose 2 electrons or one pair of electron to oxygen, because magnesium will be having 2 electron in the outermost shell. So it loses a pair of electron to oxygen. Therefore question number 1, option A. Now come to question number 2. Question number 2 is, what happens when sodium chloride melts? So when sodium chloride melts, remember that sodium chloride is an ionic compound. So when it will melt, so covalent bonds, no, there is no covalent bond in sodium chloride. It is an ionic compound. So leave option A. So option B, electrons are released? No. Electrostatic forces of attraction between ions are overcome? Yes, because when sodium chloride melts, so electrostatic forces of attraction between ions are overcome. They are get zero, and now the forces of attraction are no more and the ions become free. So option C. Question number 2, option C. Question number 3. So here the question is very interesting. The diagram shows the arrangement of particles in 3 solids. Remember, solids, all these are solids. Krypton, however, mostly krypton is a gas, is a noble gas which is in group 8. But here they mentioned that krypton is in solid state. So keep in mind that in solid state the atoms are very close and they are closely packed. Keep in mind this thing. Potassium is a metal and sodium chloride is an ionic compound. So now in which order are the solids shown? So it will be D, because in D, if you see that first of all there will be sodium chloride, then secondly there is potassium, the second diagram is potassium, and the last diagram is krypton. First diagram is sodium chloride because it is showing the ionic lattice, positive and negative ions. So it must be, first diagram is nothing other than sodium chloride. Second diagram, as it is having free electrons and positive ions, so these circles are showing positive ions and E means free electrons, so it is potassium. And the third diagram, where the atoms are closely packed, it is solid krypton. So option D, 3D. Now come to question number 4. Why does molten sodium chloride conduct electricity? So why does molten sodium chloride conduct electricity? Because the sodium ions and the chloride ions are free to move. Molten sodium chloride. So as we discussed in the lecture, that in molten form the ionic compounds, their ions are able to move freely, and when their ions are able to move freely, only then they can conduct electricity, either in molten state or in aqueous state. So that's why question number 4, option D. So thank you very much.